So here's what we're about to do there with the rotation. Every time you do a 360, it's like you're adding 0 or you're subtracting 0. I can subtract 0 however many times I want. Doesn't affect anything, right? Minus 0, minus 0, minus 0, minus 0, doesn't affect anything. So in this room, for sine and cosine, a 0 is 360 because it's a full circle. Every time I take out a 360, I start all over again. It's like I haven't done anything. Let's get back to the same spot. Over and over and over and over. How many of you driving here? Yeah, not that car, not your mom, not your parents. Right. So if you look on the dashboard of a car, besides the one that measures your speed, there's another one that has, yeah, or revolutions per minute, 360. How fast is that tire spinning, making one circle per minute?
Is it the tire or is it talking about the engine?
Both.
Okay.
So when you get stuck in the Minnesota snow, and you have a two-wheeler or a front-wheel drive, and you're right there, right? You can press the accelerator all you want. That thing is going to go all the way down here, right? Are you moving anywhere? Nah, because it's just 360s, man. It's just right there. That's what it's doing, right? It's like 0 is happening. I mean, you might be burning your tires, they're still making the snow look blacker and blacker, but nothing else is happening. So now, here's what we're about to do. We are going to be doing this thing that we're doing ancestry DNA. Okay? In order for you to do that stupid DNA testing, like everybody's doing right now, finding out where they're from and where their ancestors came from, you first have to be a human. From Earth. Because if we get a Martian here and we try to test their DNA, they ain't going to tell us where they're from because they're not from Earth. So here are the questions we're going to ask ourselves first. Is it on Earth? In order to be on Earth, it has to be between 0 to 360 degrees. Okay? If it is not on Earth, we're going to bring it down to Earth. So, is it down to Earth? If it is, what part of Earth? Are you in North America, South America, Asia, Africa, Europe? What part of Earth? We're good? When we determine that part of Earth, that will tell us our cosine value and our sine, right? The sine of the sine of cosine, plus or minus, minus or plus, 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 minus, minus, right? Based on the quadrant, right? Now that we know you are on Earth and you're in Mississippi, right? We find out that you're on Earth, you're in Mississippi, and you're black. We're trying to find out your reference angle. Where did your ancestors come from? Right? From the motherland. Right? So now that we know that, a reference angle has to always be between 0 and 90 degrees, right? That'll be the first quadrant. And then after that, now that we know you're a black person living in Mississippi, whose ancestors came from Africa, we can say, oh, this is where your ancestors were in Africa, but because you lived in America so long, through this Jim Crow era and everything else, here is what it's done to you. It's taken away all of your culture and everything. This is who you are now. You're not like your ancestors, because they had culture. But this is who you are now, because your culture got stripped away. So these are the questions we're going to be asking ourselves. So let's do one problem. Problem number 1. On page 31. Problem number 1 says we should find cosine of 450. You ready?
Yes, sir.
So let's go through these questions. Cosine 450.
Number 1,
Yeah.
that's 405.
Oh, okay. Thank you. It's like a freeway. We were driving on the 405, and the traffic was like really crazy on the 405 today. We ready? So let's go through the questions. Is that on Earth?
No.
No. It's on some other planet. It's not on Earth. So I need to get it to Earth. I need to take out a rotation. So in order for me to get it to Earth, I need to say, what would happen if I took out 360? Because the Earth is 360, right? I keep writing 450. The Earth is 360, right? So if I take out 360 from 405, what do I get? 45. Okay. Now it's 45. Now it's on Earth. Now we can talk. Right? Now you're a human. Now we can have a conversation about where your ancestors came from. Whether they were Asian, Aztecs, or Mayans. Right? We can talk about that. We're good? Now 45 degrees, what quadrant would that put me in? Quadrant 1. See that? Now I know you're from Antarctica. We're having a conversation now with the 3 people from that place. We see that? Now we're from Antarctica. Quadrant 1. What's the reference angle?
45.
It's itself, right? Because it's already in quadrant 1. So the reference angle is itself. So 45. You see that? Now we go to page 26. Please make sure you kind of mark page 26 so you can easily go back and forth to page 26. Because on page 26 is where we have that nice, fun-looking arc that gives us the values for most of the angles that we need. Everybody see that? On page 20. See 26? Maxie? You don't have 26 in your book? 26. There you go. Okay. Now, looking in quadrant 1, on page 26, what is the cosine value of 45? Huh? Square root of 2 over 2 is the value. Okay, so what is the sine value also for that same thing? The same thing, right? Our 45 degree sine and cosine have the same value. That's what tangent is 1. Everybody see that? We see how we just went through the whole thing. Are you on Earth? If no, can we bring it down to Earth? I'm thinking, my man, I can have a song about that, right? Right? Because you can't see me if you're on Earth. John Cena stuff happening if it's not on Earth when you're talking.
Is that supposed to be the rat?
Oh yeah, because this is the LOG, Black Pop. They're an original gangster. LOG. Like we're OG, and that's about 50 cents. It's approximately 50 cents. So 50 cents will call himself the LOG. Pop! You know that. So let's do the next one. Okay? Again, this idea is we're peeling our rotations. We can't only peel out one. If we peeled out one and it's still not on Earth, maybe it was on Jupiter, now it's on Mars, we gotta still take some away. Right? You gotta keep doing 360s. It's like you're doing the backflip over and over and over until you land that perfect stuff, right? Gymnastics, right? That's all we're doing. Okay? See that? I just landed. It's just a 12 out of 10. Yeah, I get extra. Yeah. Okay, so let's do the next one. 840. We're given 840. Is it on Earth? No. So we take out one rotation. Would they still be on Earth?
No.
No. We got to take out 2 rotations, right? We do it. And here, people who don't realize that, here's what I did for your cousins. For those people who suck at multiplication. One rotation is 360. 2 rotations, 720. 3 rotations, 1080. 4 rotations, 1440. There you go. Okay? So now, if I had 840, I'm going to take out 2 rotations. See that? To bring it to Earth. This is way, way up there right now. You do acting like you're all there right now. I'm going to need you to bring that down a little bit. Right? Like, get on my level. See what? Right? That. So bring it down a little bit. Okay? So if I take 720 from 840, I get 120. So when I bring this thing to Earth, it looks like 120. See that? So in your notebook, you should be marking these bullet points on every problem. Bullet point number 1, is it on Earth? Yes or no? No, bring it to Earth. And then you do your bullet point number 2, and then you determine the quadrant for each of those problems. So that when you study, you know what we're dealing with. Okay? Now that we have 120, what quadrant will 120 be in? Quadrant 2. In quadrant 2, what is the value of the cosine looks like? Negative or positive in quadrant 2? Negative. And the sign? Positive. Okay. So now when I come to my value, I know what to expect, right? So I got you in quadrant 2, right? So I got you in Scandinavia. I know your folks came from Scandinavia on some boat and ended up in Minnesota where they cheer for a losing team, right? Score! Okay, right. Okay. So now that we got 120, what's the reference angle? 60. How did we get it? 180 minus 120. Okay? So 180 minus 120 is equals to 60. That's our reference angle. You see that? Now that we got that reference angle, let's go back to the beginning. We're all looking at page 26. 60 degrees. What is the cosine value of 60 degrees? 1/2, right? 1/2. But because this thing came from quadrant 2, it should be a negative 1/2 for the cosine. We see that? The sine value for 60 degrees in quadrant 1 is the square root of 3 over 2. This thing came from quadrant 2, sine is still positive. Everybody see that? We're good? So I need everybody to take like 2 seconds and do problem 3. 2 seconds.
Ooh, and do 3?
Okay. What is the angle measurement we're given?
It's 1,680. Is that even an angle? How do you do that?
Oh yeah. This is how we do that. 1,680?
Yeah.
Is it 2 away rotations and you get what you get in the game. That's the reason it's not on Earth. We can't even do anything about it. That is way up there. So 1680. Somebody talk to me. Who got answers? Is it on Earth?
No.
No. Because it's way more than 360, right?
Yes.
How many rotations do you got to peel off to bring it to Earth?
4.
4 rotations. So when I subtract 1440, from there, what do I get left with?
240.
All right, let's think about it because they're conflicting answers. Look at your work again. When you subtract 1440 from 1680, what do you get?
240.
240. Will I agree with 240 now?
Yeah.
Okay. So 240 is what we get. Now that it's on Earth, it's 240. What quadrant would we find that in?
3.
In quadrant 3. In quadrant 3, what is the sign of the cosine and sine? They're both negatives. So my answer I get in the end better be negatives, right? Otherwise I have a problem. You see that? Now what's the reference angle? 120, right? But the reference angle can't be 120, can it?
No.
No. Because 120 is not in quadrant 1. I get what you did. You had 240, so you did 360. Did you do 360 minus that? Okay. So 360 minus 240 is 120, right? Correct?
Yeah.
But 120 is not in quadrant 1. So we got to take this away from 180, right? So then we'll do 180 minus 120. Oh, we just get 180 from that thing. So what do we get, 60 degrees? Right. So 60 degrees now is the reference angle. You see that? Now we go to quadrant 1 on page 26 and read out the value. But we already know that we already dealt with 60 degrees earlier, right? Just in different quadrants, right? So the cosine of 60 degrees is 1/2, but because it's in quadrant 3 is a negative 1/2. And the sine of 60 degrees is square root of 3/2, but because it's in quadrant 3 is negative square root of 3/2. Okay? So if you think about this, what this 1680 is telling us is we started here, we did one revolution, well, this is smaller, I'll go around the inside. We started here, right? So I made one revolution, that's 1, that's 360, right? And then I made another revolution, that's another 360. But we said there were 4 revolutions we took out, right? So we did another one. There's 3, still not on Earth. And then we did another completed one. That was 4. And then when we did that, we got left with 120. So this is 90. So it's in this quadrant, right? 90 plus what gives me 120? 90 plus 30?
30.
Okay. So, if this is where it stopped, then this leftover piece right here is 60 degrees. Right? Because it's 30 plus 60 degrees is 90 right here. So this thing is spun and then stopped. So we throw it out, all of the revolutions, all of the perfect rotations are all 0. We just throw them out and see what we're left with. Like a crop circle. Right? Questions? Anybody with a question?
So what's the No, no. Don't do that. Don't touch me. Oh my God.
Okay, now I
Don't
think I
put
already
you.
but we took 180 minus 120, and then how did I do
Just 60. Go page 26 and look at an angle measurement of 60 degrees.
so that determines your answer.
Okay? So, now, let's look, you're going to do the rest of those things on page 31 that I haven't done. But let's look at exercise 6 at the bottom of that page.
It's negative.
They're asking for negative 30 degrees. We need to determine where on earth that will be. All right, anyways, hey, pay attention. Guys, if you watch here, hello. Hey, if you watch the rotation from here, we went this way, right? To count our rotations in positives. If we're going negative, it's just telling us to go the opposite side. So we're going to go this way. You see that? So negative 30 means I started here, and instead of going this way, I came back this way 30 degrees. Okay? That's negative 30. You see that? That's negative 30 degrees. So what is the value? What is the positive equivalent of negative 30 degrees? In order to find that, is most of you seen that stupid stuff like give you directions when you're going places, right? GPS. You put in the address you want to go to, and if they're very, very smart, they give you options. They say which way you want to go. You want to take 94, you want to take 100, you want to take 394, you pick up, and then it gives you how long it's going to take you. Some of them will say, you know what, there's a lot of traffic, so I'm going to take you the longer route, but you're going to get there anyway. So you start at here, they take you this way, plus 90, plus 90, plus 90. Now if this is 30, this is plus 60, right? And they get you right here where you wanted to be. So that would be 90 plus 90 plus 90, that's 270. What's 270 plus 60? 330. So you took 330 degrees to get here. Or some GPS will go, you know what, we got traffic, but I'm going to take you through some neighborhoods, and we're still going to get there. It's going to be shorter. So you go from here and just come right here up, have a route. Right? So 330 degrees is the equivalent of negative 30 degrees. So if you give me negative 30, I'm going to convert that to the positive piece because I want to know if it's on Earth. And so the positive equivalent is 330 degrees. Now that we have 330 degrees, is it on Earth?
Yes.
Yeah, 330 is on Earth. What quadrant is that in?
4.
See that? In quadrant 4, just like the negative 30 was. What is the reference angle for 330 degrees?
It is 30.
30 degrees. And then you find a sine and cosine. It's almost like here is the border town, right, at El Paso. This is the Mexican side of the border, this is the American side of the border. We got two kids here. They're the exact same humans. It just depends on which side of the border they are, right? We're just talking about where you are. Are you on the other side, on the other side? But we stay all humans, right? So don't build no damn wall. So, your homework in page 31 and 32. 31, 32. You're doing all this stuff on that 31 and 32. So you got a long vacation coming out. Watch the videos. It makes no sense for me to keep doing these episodes because I could be out there in Hollywood making movies, right? Because this is copyrighted material. But I'm here doing these episodes in Washington. I'm going to get my TV cancer, right? If it's small letters, having more deals than me at this point, right? Can't be having that. Yeah, right? So LOG, Black Pie, out.